Hello, everybody. This is Coach Meidenbauer here for AP PreCalculus. We're going to be working on sections 4.1 and 4.4. They do relate to each other. They do correspond. So we're going to combine these into one set of notes here for you. Do not forget to like and subscribe. And here we go. So we're going to start learning about parametric equations and lines and circles and all that fun stuff. What parametric equations are is it's two sets of equations that have a parameter known as t. So instead of having just an input and an output, we have this t parameter which affects the x's and affects the y's. First thing we're going to do here is we're going to start graphing them, and we can kind of dive into a little bit more about what they represent when we get into the graphing. So example 1 here says to make a table of values and sketch the curve indicating the direction, and that's important. You have to indicate the direction for parametrics. And then we're going to eliminate the parameter afterwards. So we're going to do a couple things here. So for this first one right here, I don't have a t limitation. I don't know what t should be. So t's domain essentially, or range, however you want to think of it. T can be any value. So I'm going to make a chart here. So when t is something, what's x at that value and what's y at that value. So just by kind of looking at this and guessing what I'm going to be using here, what's going to fit my graph. I'll just start with t equals 0. I could have started with -1 or -2. Might have fit my graph as well. So at 0, this right here is the x. And this right here is the y. So I could write this as x equals 3t minus 4. And y equals 2t plus 1. Okay, I could have written that way. So when t is 0, x is -4. And y is 1. I'm going to plot that point. -4, 1 is right here. When t is 1, x is going to be -1, and y is going to be 3. So -1, 3. When t is 2, I'm just going to keep going until I can't fit anything else on here. I'm going to get 2. For x, and for y, I'm going to get 5. And it looks like that's going to be about it. Nope, I can't count. Still looks like it's going to be it, though. So 1, 2, 3, 4, 5 up here. Okay, so I'm going to connect these, and this actually makes a line. So I'm going to connect all of these together. It says indicate direction, so we're going in this direction. So I always put extra arrows in the middle. And actually even put a little tail here at the end because we're indicating what direction this is going into. I'll just put another one right here. Maybe a little overkill on all these arrows, but direction matters a lot with parametrics. Okay, and now we're going to do something called eliminate the parameter. Eliminate the parameter means that I'm going to solve for either t equals x some sorts or t equal y of some sorts, and then we plug into the other one. So just because I'm going to solve for t equals on this one right here on the x. So if I were to solve for t, I add 4 to both sides. I'm going to get x plus 4 equals 3t. Divide both sides by 3. I'm going to get x plus 4 over 3 equals t. And then I'm going to substitute this in for here. So I'm going to actually do this right down here. So y is equal to 2 times x plus 4 over 3 plus 1. We did eliminate the parameter. This is totally 100% correct. I do want to clean this up a little bit, though, so we can make a little bit more sense of it. So y equals, if I distribute that, that's going to be 2x plus 8 over 3 plus 1. I'm going to divide each of those by 3. So y equals 2/3 x plus 8/3 plus 1, which is actually going to be 2/3 x plus 11/3. So this is a line. That's a slope of 2/3. And you can see that from my dots. If I go up 2 over 3, perfect. 11/3 is a little bit over 3, which it looks like that is the case here. So there you go. That's the equation of that. Now it's going to ask me down here, what's the slope of this line? Now we said it's 2/3. I do agree with that because of this right here. But we can also get that from our t values if we have two linear parametric equations. So 3t minus 4 is linear, 2t plus 1 is linear. So we can always do change of y over the change in x. Okay, actually, I'm going to undo that writing so it's not on the key. I forgot how to undo. Oh, there it is. Okay, so I'm going to use those values. So how do we do this? We're going to look at the t's at the t coefficient. So that's why it's going to be 2t over 3t, because it's really change in y over change in x, which is just 2/3. Okay. Moving on to the one that's not linear. So for b here, we're going to do almost everything the same, except now we're given t values we have to use. So I'm looking at my same chart here, my t. I'll do this in red. So look at my t chart. So t, what's my x value and what's my y value? And again, if you're a little lost here, what's what? X is equal to t squared minus 1. Y is equal to 2t. And we're going to start, it gives us limitations on the t's. It says we're going to start from -2 and go all the way out to 3. So -2. If I plug in a -2, my x value is going to be 3. If I plug in a -2, I'm going to get -4. I'll plot all this in just a second. If I do t equals -1, that's going to give me a 0 value for x. It's going to be a -2 for y. If I plug in a 0, it's going to give me 1. It's going to give me 0. If I plug in a 2, t is going to be 3. Then we're going to go with, oh, why did I just select 2? Oh, silly me. T equals 1, goes back to 0, and this goes to 2. If I select a 2, that's going to give me x is 3, y is 4, and last but not least, we're going to plug in a 3, and that's going to give me 8 and 6. Okay, I'm just going to plug in all these points now into here. So I'm going to go 3, -4, 0, -2. 1, 0, 0, 2, 3, 4, and then 8, 6. I know something's wrong here. I'm guessing it's my middle one. 1, 2, 6, 7, 8, 6 would be like up here. I can tell this one's wrong because I can't do math. This should be -1 right here. See? Even I, the teacher, make mistakes. Okay, so we start here, this one, and we just continue. This one has no arrows at the end because I am confined between the t equals -2 and 3. I'll just put 2 arrows right here in the middle so I can indicate the direction. And let's go ahead and eliminate the parameter. It's probably easiest to solve for t to equal y over 2 when I'm using this equation up here. And then so for my x equals equation, x equals, instead of t squared, it becomes y over 2 squared. Sorry, I can't fit this all on the screen at the same time. Minus 1, which means that x equals y squared over 4 minus 1, which indicates that we have a sideways parabola because it's an x equals y squared type of an equation. Okay. There are limitations, though, because we have t's being bounded. That means that our independent variable inside of this equation is be bounded as well. In this case, how our equation is written, the y is going to be what is bounded. How are we bounding y? Look at our graph here. The lowest y value is -4. The highest is 6. So from -4 to 6. All right. Let's move it on to this one. Again, just the side, I'll write down what these are. Again, x equals. This is a fun one. And then y equals -3 plus 4 sine t. Okay, anytime we have the sine and cosine, what we're going to do is we're going to pick t values that are on the quadrantals. If you don't remember what that is, go back to your old notes and look it up. Or you can just keep listening to this video because I'll tell you like in 3 seconds. Quadrantal angle is anything that is where the unit circle sits on an axis. So quadrantal angles are going to be 0, pi over 2, pi, 3 pi over 2, 2 pi, stuff like that. So at t equals 0, pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to do all those. So when t is equal to 0, for x, I'm going to get cosine of 0, which is 1. So I'm going to get 1 plus 4, which is 5. And then for the y, since sine of 0 is 0, it's going to get me negative 3. At pi over 2, cosine is 0, so I'm going to get 1. And sine at pi over 2 is 1, so I'm going to get negative 3 plus 4, which is 1. At pi, cosine is negative 1, so we're going to get negative 4. 1 plus negative 4 is negative 3. And again, sine is 0, so the y value will be negative 3. 3 pi over 2, I'm going to get 1. And then sine is now negative, so I'm going to get negative 7. And 2 pi is going to be the exact same thing as 0 here. So I'm kind of looping around. So when I graph this, I'm going to have 5, 1, 2, 3, 4, 5, down 1, 2, 3, 1, 1, negative 3, negative 3, 1, negative 7. A little bit off the graph there. And coming back here, this is actually going to make a circle. Just trust me. And it's going in this direction. That's enough arrows. Okay. So in terms of a clock, it's going counterclockwise. Now we want to eliminate this parameter. This one's a little bit weirder to eliminate the parameter. But once I show you this trick, you'll be like, oh, that wasn't that bad. Okay. It's hard to solve for t here because I don't want to use inverse cosine, inverse sine. It's a lot of work. Instead, let's go ahead and use this equation that we are familiar with of sine squared t plus cosine squared t, which equals 1. And what I'm going to do here is I'm going to solve for sine and cosine in each one individually and then plug them in. So for the x's right here, cosine of t is equal to x minus 1 over 4. Because all you have to do is subtract the 1 on both sides, divide by 4. And then the sine of t is equal to y plus 3 over 4. So I'm going to get the sine squared is going to be y plus 3 squared all over 4 squared, which is 16, plus x minus 1 squared all over 4 squared, which is 16, equals 1. And I'm going to multiply everything by 16, and I'm going to get y plus 3 squared plus x minus 1 squared equals 16, which, by the way, is the shape of a circle where we are centered at the x value is going to be 1, the y value is negative 3, and you can tell that by looking at right in there. Okay, so right below is the parametric equation for a circle that's centered at HK. You can go ahead and look at that and just tell. Okay. Last example here is now I want to produce parametric equations. So we just did a bunch of things where we're going from Cartesian or from parametric down to Cartesian. That's what we like. We like Cartesian. We're familiar with it. This one is going to give us Cartesians. And then I'm going to go ahead and transform this into parametrics. Okay, so I do have some steps down here on how to do that so that you know. I'm going to kind of sort of follow it a little bit. I might end up doing my own thing here, but I believe the steps I do correspond, maybe just not the exact same order, exact same outline, but there we go. So what I'm going to be using, I'm using these equations. X equals initial x naught. You might hear that in physics. X naught, x sub 0. That's the initial x value plus t times change in x. And y is the same story, but with y's. Okay. So what I do is I label these. This is x naught, and this is y naught. This will be x1, y1. Now, for these equations, these are interchangeable. You can use x naught, or you could use x1 It's got to correspond with the y, though. If you use x naught, you have to use y naught. If you use x1, you have to use y1. I just stick with x naught. And then change in x represents x1 minus x naught. Change in y represents y1 minus y naught. I could have made a joke there. I'm getting rusty. Okay, so for this equation right here, I'm going to find my change in x. So my change in x is going to be 3 minus -1, so I get 4. My change in y is going to be -2 minus 3, which is -5. So my x equals equation is going to be my x naught, which is -1, plus 4t. My y equation is going to be 3 minus 5t. And there you go. That is not the only correct answer. Okay. You could also use y1 if you wanted to, or use x1, y1, in which case you would get x equals 3 plus 4t, y equals -2 minus 5t. They're the same thing. Just timing wise, t equals 0 is going to produce a different value for the top box versus the bottom box. But you'll still get the same direction. You'll still get the same points. If this was limited with the t values, then it'd be a different story. And we don't touch that. So there you go. There are our notes for 4.1, 4.4, which is everything to do with parametrics, including lines and circles. Do not forget to like and subscribe.